Good evening, everyone. Tonight, we would like to remind everybody of the house rules. I think you've seen them on the screen, but emphasis on the reminder. Please note that your questions will be entertained for as long as you type it in the Q&A box. On FB Live, if you would like to participate through there, we will also try to take note of your questions. So tonight we are very privileged to have with us from the United States, Mr. Moses Alcala, and he will be speaking to us about something that we might not be so connected with when it comes to the issues that we're going to be talking about, which is the intended or the proposed 174 hectare reclamation in our coastal areas. So this learning event is a series that is brought to us by the Dumaguete City Host Lions Club and the Rotary Club of Dumaguete South. And before we proceed, perhaps it would be nice for us to track back a little as to why we need to see what the geological impacts are of a reclamation of our coast or the sea. So I would just like to read this to you. What is a geologist, or what does a geologist do? A geologist is someone who works to understand the history of the planet that we live in, so that we are able to better predict the future and explain current occurrences. Geologists study earth processes such as earthquakes, landslides, floods, and volcanic eruptions to survey land and to help us draw safe building plans. So tonight, as I mentioned, we have Mr. Moses Alcala with us all the way from New Jersey, and to give you a very brief background of his career. He has had a long and fruitful one in environmental geology, and he works with Environmental and Geotechnical Services, which is a limited liability company in the United States, specifically in New Jersey, and they cater to various services. He practices as an environmental geologist and hydrogeologist and specializes in environmental investigations and cleanups in the state of New Jersey. He is a licensed site remediation professional in the same state and is a licensed professional geologist in the states of Indiana, and Arkansas. In the Philippines, he was a top-notcher in the boards when he started his career. And tonight we welcome so much the information that he is about to share with us with regards what we might expect should this 174 hectare reclamation, or what I learned from last night is actually island building off our shores. Good evening, everyone, and welcome to tonight's learning session with Mr. Moses Alcala.
Hello, everyone. Good evening in Dumaguete and good morning in New Jersey and the rest of the states. Thank you very much, Lions Club and Rotary Club, for inviting me to talk about the geological impacts of the reclamation project. And I would like to present some of the hazards, the geologic hazards that might apply in this case. I would also add some of my opinions as we go along. By profession, I was actually a petroleum geologist at the start as a government regulator in the Philippines for about 7 years, and then an environmental consultant for 30 years now thereafter. I am a certified LUMAD. I grew up in Dumaguete. I swam and snorkeled and scuba dived in the waters of Bantayan and Piapi. And as a student of geology and later on as a professional geologist, I studied, albeit informally, the coastal processes along the Dumaguete coastline, as well as coastlines of other towns in Negros and other islands in the Visayas. As a member of the alumni umbrella organization, SUACONA in the States and Canada, I am proud to mention that we have recently sponsored a research project on pollution along the beaches of Bantayan and Piapi,
Mm.
the results of which will provide us the status of our precious resource, the last remaining recreational beaches of the city. You have probably heard about the impending monumental destruction of the marine life resulting from the reclamation project. As a geoscientist, I will present certain geologic hazards that should also be considered. I'd like to share my screen. This is a view of the recently completed reclamation project, which I think is referred to as the Pantawan 2. It covers a portion of the Rizal Boulevard, an area of about 1.8 hectares. The original coastline runs along this line as you follow my mouse arrow here. So all this is about 1.8 acres. The newly proposed reclamation covers much more than this. In fact, about 100 times almost the size of this. And it goes towards the town of Bacong, away from the picture here, and towards the north, towards Look and Piati, outside of the picture here. You will note, just from this picture, that Dumaguete is actually a convex. If you look at this from a map point of view, it's a convex. It's like round over here, facing the ocean. And I will make an issue of that um, geographical fact later on as I go along with my slides. I would like to start with a presentation of what I know about some of the reclamation projects around the world. And one of the most popular projects is probably the Dubai projects.
Sir, Mr. Alcala, excuse
Yeah,
me, may I
that's
there?
right. So, all right, let's try to get back to where we left off. And again, I apologize for this. Um, this this is the more popular or the famous reclamation project in Dubai, and it's known. This one on the top is known as the Palm Islands Reclamation Project, and this one at the bottom is called the World Islands Reclamation Project. Um, these are artificial islands that were made for use as residences, hotels, and recreational events in Dubai. And as you probably know, Dubai is located in the eastern coastline of the Persian Gulf, and the reclaimed islands were built within a very shallow sea um, in an area with depths of less than 15 meters. Next slide. Okay, so this is a nice colored map. If um, you are not familiar with this type of map, it's called a bathymetric contour map of the Persian Gulf. The areas outside the Gulf are blank here, white. This is land, and over here is land again. So These colored areas show different depths in the ocean, in the Persian Gulf. And I would like go back, please. Yeah, I would like to do a quick lesson on what a contour map is. Contour lines are lines that connect depths, that connect depths in the bottom of the ocean of the same elevation. For example, if we look at this line here, it says 20 meters. This line connects all the depths that are 20 meters below sea level. The next one you see is a 40-meter contour line. This is the depth that connects the deeper parts, all within the 40-meter depth. And here in the middle is an oval that says 80 meters. So this is the middle part of the sea, which is the deepest part of this inland sea. The slope of the bottom of the sea is considered very gradual or gentle when I compare it with many ocean bottoms. For example, here in the Philippines, um, it is an inland sea that is considered very shallow. The, the slope of the bottom of the sea drops at about 80 meters over a distance of 7 kilometers along this line. So from the Dubai part here, if we go towards the bottom of the sea, that's about 80 meters over 75 kilometers, or a slope factor of about 0.1%. That is very shallow. That is very gentle. Note that to the right of this Persian Gulf is what we call the Arabian Sea, which is pretty much pretty deep and um, part of a larger ocean that is um, huge and covers a major part of the continent there. Um, this this contour line shows you that it's at this depth it's like 2 kilometers deep. This area is exposed to a lot of wave action and storms. One thing that you will also see from the contours here is that the contour lines are very close to each other. So from the land towards the sea, you have a steep drop in the bottom of the ocean, as opposed to here in the Persian Gulf, you have a widely spaced contour lines, which tells you that the slope at the bottom is gentle. Next slide. Next slide, please. Okay, this is another view of those two reclamation projects, this time from a satellite. Geologically, this area is stable. There are no significant faults here, and earthquakes are rare. Next slide. This is another example of a reclamation area and probably familiar to many of us. This is the Manila Bay. The original coastline of the Manila Bay runs along this line here. And I think we lost the slide. I'm sorry, did we lose the slide? There you go. I'm sorry about that. Okay, this slide shows a topographic map. Uh, the next slide, I'm sorry. Next. Next, please. Next. Okay, these are maps again showing the Manila Bay area. By virtue of its geographical or morphological configuration, it has natural protection from extreme waves that normally occur west of this area in the Luzon Sea. The seafloor depth is also shallow with a maximum of only 40 meters, as you can see in this color picture here. Now, the slope of the seafloor from land here, which is yellow, down to the deepest part is only about 0.14%. So that is, again, another thing that I want to note, because that is a gentle slope considered when we consider our situation in the Philippines, especially around Negros. While the eastern part over here of Manila, Metro Manila, has an active fault, the Marikina Fault. The Manila Bay area here has no major significant faults, geologic faults, that is, and there is lesser degree of um, earthquake hazards as compared to this eastern part of Metro Manila. Um, Going back to this picture, the original coastline of Manila Bay actually runs this way and that way and this way. The irregular configuration of this yellow colored uh, part land is because of the reclamation projects. There's a whole bunch of them over here, over here, over here, and over here. And still, there are more projects that are in the pipeline from what I hear. Next slide. This is the bird's eye view of the SRP reclamation site in Cebu, which you probably have seen a lot of pictures of. The SRP is the South Road Properties reclamation site. It has been completed. It was mostly developed within a very shallow sea over here, and it covered what were once wetlands. Um, this area is naturally protected from extreme storms and waves due to its location between Cebu and Mactan Island here, which is outside of the picture. Next slide. Okay, this is a topographic map showing the SRP site, which has been completed. And in fact, this also shows the proposed Cordova site in Mactan Island, which I think is about to start anytime soon with their huge reclamation project. What I'm trying to show here is that the SRP site especially, um, is located in a relatively shallow sea or channel over here. If you take a quick look at these numbers, a close look at them, you would see that these are all below the 20-meter depth. So that is very shallow. It is also naturally protected from major storms and waves by virtue of the presence of Mactan Island, Cebu Island, and Bohol Island, which is outside of the picture on this lower right corner of the slide. Next slide. Okay, now let's go to Dumaguete. The city sits at the eastern corner of Negros Island, and it faces the open sea, also known as the Bohol Sea or the Visayan Sea. It is open to this predominant wind here, called the Amihan winds coming from the northeast, and also exposed to milder winds such as the Habagat and the Timog winds. But note, however, that the Habagat, even though it is milder because of protection from these high elevations here, Mount Malinis and the mountains next to it, um, even though they are not as strong as the Amihan northeast winds. When the storms come associated with Habagat and Timog, they are devastating to Dumaguete City. In addition to winds and storms, we have ocean currents, which are pretty strong as well. The Bohol jet current goes this way and curves downward to the south along the coastline of Darwin and Sambuangita and Chaton. Um, and you also have the Tanyan Strait current, which is also pretty strong going from north to south, although this current I hear also reverses with tidal action. So there is major erosional processes that Dumaguete is exposed to by virtue of its location. Next slide. Many of you may have already seen this map. It shows the two islands in white shade here. But what was not shown in the original maps is this yellow rectangle here that I have added to this map. This is the recently completed Pantawan 2, and which actually, if this project is completed, leaves us a small gap in here, which is in front of Silliman University, as well as one block of commercial institutions to the south of Dumaguete City. This project, as you probably have heard, covers about 7.2 kilometers. And what I would like to emphasize here is this is long, but the width is very narrow. It's an average of about 300 meters wide. And I will explain the reason why they had planned to do this instead of making a really one huge um, area that is not um, long as 7.2 kilometers. You saw in the previous slide how Dumaguete is exposed to high energy erosional processes. By virtue of that, of those high energy erosional processes, that should be enough reason to avoid constructing reclamation projects along the coastline. But there is an additional geologic hazard that I am concerned with, and I will show that in the next slide, please. This is a nice 3D map showing the bathymetric profile of the ocean next to Cebu, Negros, and Siquijor. The project, by the way, this map is provided courtesy of the BlueNomads.org and the Silliman University Marine Lab folks. This has been just recently completed, and I don't believe it has been formally published. This view is looking from north to south. The project over here by Dumaguete is precariously situated along a very narrow continental shelf of Negros Island. The continental shelf of an island is also known as an insular shelf, but I would prefer to use continental shelf only because it is more popular. The edge of the continental shelf from shoreline to approximately going out to a 20-meter depth is only about 250 to 450 meters from the shoreline. Beyond that is a unstable and steep continental slope being represented by these light blue bands over here. In Siquijor, you can see it more clearly with this light blue area here. That is the continental slope where you have relatively steep slopes and where you have a drop off from a relatively flat continental shelf going down into the deep ocean, which is represented by the deeper blue colors over here. The thin white bands over here, by the way, these are not sand, which are easily mistaken as sand, and I believe these are the shallower portions of the sea. My concern is that earthquakes, which are typically common in Negros, could potentially cause collapse of continental slope areas because these slopes are relatively steep, and I'm sure many of the areas of the slopes are unstable. Next slide. This is another bathymetric contour map of the seafloor off of Dumaguete, thanks to the Silliman University SUA CREM institution for providing this map. This is, by the way, a draft map and has not been published. These are the bathymetric contours starting from the shoreline over here. By the way, the project is outlined as the green outlines over here and over here. The project being on the continental shelf. Further seaward, there is a continental slope from here going down over here with a range of 14% to 25%, which is very steep when compared to the slopes associated with other major continents of the world. The slopes of the continents usually range from 2% to 5%, and the slopes that I showed before of the other reclamation areas are actually in decimal places, 0.1 and 0.14. So our slopes here are very steep at 14% to 25%. For science sake, let's take a quick look at these bathymetric contours. An interesting feature that I would like to show is the abundance of underwater canyons. One over here, about 3 canyons over here, and 1, 2, 3. These are kinks in the contour lines. And note that we have a bunch of canyons right off of Banica River, right here, very close to Banica River, only about 1 kilometer away. Now, these canyons are where underwater rivers, actually underwater, not just above the land, but underwater, consisting of dense sediment-laden waters that flow downward along the continental slope. And these are the fact that they are obvious here tells us that these are active canyons. So we have a relatively unstable continental slope of Dumaguete. Next slide. So let's go to the topic of fill materials. Due to the very large area, 174 hectares, and the depth of filling of that reclamation area as required by the project, there will be millions of cubic meters of fill material that will be needed. One very rough estimate is around 27 million cubic meters, and that's to bring the elevation of the island, the proposed island, approximately 2 or 3 meters above sea level. That is a lot of materials. Quarrying of dry riverbeds is probably what they want to do, as well as dredging. It's possible that they will do some dredging from the river, as well as dredging from the ocean. It will take a number of years to complete, causing disruption of the ecosystems, as well as widespread pollution by sediment plumes. As you will see here in this picture, there's quite a bit of sediment floating in the river, and this would be discharged ultimately towards the ocean and thereby affecting the fisheries and the marine life in the ocean. Next slide. This is a suction dredger um, dredging material from the bottom of the ocean in this part and moving it towards the island that they are constructing over here. If you watched the talk of Dr. Kent Carpenter yesterday, he discussed in detail how the island building project was implemented in the South China Sea and how such activities have affected the marine life there. Now, dredging near the project area in Dumaguete and dumping and filling of the island area will take a number of years due to the large volume of material needed. It will create sediment plumes in the sea, in the Bohol Sea, and will cause adverse effects on the marine life, including the dolphins and the whales that are protected by Philippine laws. Dredging and filling would take years, and the resulting plumes could travel a significant distance and affect the marine life not only in front of Dumaguete, but also in neighboring towns, as mentioned by Dr. Carpenter yesterday. Next slide, please. This is an artist's rendition, actually, I'll call it a clean rendition of the new island that is being planned for the front of Dumaguete. This is Banica River, and there will be a lagoon over here that apparently will be created between the island and the original coastline. This lagoon is one of my concerns because it will be subject to flooding, it will be subject to pollution because of stagnation and just plain negligence of people. And another thing that is a possible geohazard is it would cause liquefaction along the coastline, especially the original coastline, and possibly within the new islands, depending on how they construct it. Additionally, we don't know, and no study has been done regarding how the mouth of the Banica River is going to be affected, because apparently if you block the mouth of the river, the various processes, the dynamic processes that occur at the mouth of the river will be disrupted. Sedimentation, deposition of the silts and the sands, the currents and the waves have not been studied. So all these could cause flooding, for example, and that would be a major concern. Next slide. This is just a collage of many instances of flooding of reclaimed areas around the world. So if somebody, or if you do a quick Google search, it is very easy to find reports of flooding in reclamation projects from various countries like China, and even in Bacolod, Manila, Jakarta, Indonesia. Next slide. Next slide, please. Okay, so let's go to what we call geohazard maps of Dumaguete. I have enlarged this from the compilation of hazard maps by the PHIVOLCS, the Philippine Volcanology and Seismology Institute. On the left here is the liquefaction hazard map, while on the right is the tsunami hazard map. This liquefaction hazard map shows a large red band just along the coastline. This is the high risk areas for liquefaction. And then you have the purple area, which is the moderate risk, and then you have the yellow area, which is the lower risk. This area, all this area within the Dumaguete boundaries consists of or comprise 40% of the total area of Dumaguete. And unfortunately, even though it's only 40% of the area, 75% of the population live in this area. In the tsunami hazard map, it shows a smaller area, although the inundation by any extreme tsunamis range from 3 to 5 meters in these pink and purple areas and up to 1 meter in the yellow areas. Together, this tsunami area along the coastline from yellow to purple consists or comprises 13% of the city's area and affecting 25% of the population. Now, if we add the reclamation project over here along the coastline, we would certainly add to those statistics of possible inundation by tsunami. Next slide. This is an example of failure of a reclamation area. This was somewhere in Philadelphia. And it shows you the bulkhead here, which was supposed to protect the field areas here, has collapsed. And you can see the actual field area underneath this structure in here. And I believe this had been caused by some kind of liquefaction issues. Next one. This is another example of liquefaction. These are collapsed buildings in Japan due to earthquakes. So liquefaction is when the soil underneath the buildings or any structures like roads get saturated with water and the soil loses its cohesive strength. So when earthquakes hit that area, the soil typically just collapses and the buildings over it start collapsing. Next slide, please. This is a highly technical map. If some of you may have seen this map already. It's called a geologic or tectonic map of Negros and the surrounding islands. A little lesson on geology here and tectonics. All the way to the left here is a black line with triangles. This represents what we call a subduction zone, where the Sulu Sea plate or crust is actually diving underneath this other crust in here, this other plate. It's called subduction zone in geological terms. The subduction results in the formation of magma underneath the crust, and the magma in turn results in formation of volcanoes over here. So these are volcanoes, some of them inactive, including Mount Talinis, one of them still active, Canlaon, Mount Mandalagan and Silay are also inactive volcanoes. So this is the volcanic arc resulting from subduction along the Negros Trench. So this subduction causes earthquakes. Not only earthquakes, but it helps or assists in the formation of faults. A lot of faults are shown in this map. These are represented by dashed lines here and here. And here in Cebu, Negros, I think we have 1, 2, 3, at least 4 significant geologic faults. And if you're familiar with faults, the faults have something to do with a break in the Earth's crust, and when there's movement in the faults, either sideways or up and down, you cause earthquakes. And this star here, especially, uh, is here because it represents one of the most recent geologic events. There was an earthquake in 2012. That earthquake actually caused a tsunami in the town of Tayasan. That tsunami actually brought inundation of as much as 5 meters above the ground and caused quite a bit of damage. Lucky that it wasn't a highly populated area. Next slide. This is another geologic map. It's supposed to show um, historical incidences of major earthquakes and tsunamis. And I am having technical problems again. It's not coming up. All right, there you go. I had the same problem last time. I apologize for this. But this blue band over here represents tsunami inundation sometime in 1868. And over here, which should pop up hopefully in the next few seconds, there was a 1922 earthquake near Apo Island. And that earthquake in 1922 generated a tsunami that inundated Dumaguete and a whole bunch of towns south of Dumaguete. So this shows a tsunami risk just based on that major earthquake in 1922. This band is a result, a tsunami inundation of an earthquake off of Bayawan. Next slide, please. Oh, there you go. Finally, here's a 1922 earthquake. 1922 earthquake that I was talking about off of Apo Island with a magnitude of estimated 6. Another one in 1925 with a magnitude of 6.8. Here's a big one with a magnitude of 8.2 in 1948 off of Panay. So all these bands, colored bands over here, shows us the coastline, the portion of the coastlines that were affected by tsunami inundation brought about by these earthquakes. Here's the 2012 earthquake in Tayasan with a magnitude of 6.9. This is the next slide now. This is the earth shaking hazard map of southern Negros. And this red shaded area shows us a very high risk of earth shaking, of ground shaking hazard. In other words, ground shaking is the same as earthquake hazard areas. 100% of Dumaguete City is now under this hazard area. Next slide, please. So these are my conclusions. There are too many geologic hazards and potential risks associated with a proposed project. And another statement I could say is that, and this is my opinion based on my studies, is that the Dumaguete coastline is the wrong place for a reclamation project. based on geologic hazards and many other reasons that are not discussed here, but obviously have already been discussed by other people. Thank you very much for attending, and I apologize for my technical difficulties. Blame it on my new computer. Thank you very much.
I don't think there was any need to apologize, Mr. Alcala. I think by now this is kind of the new normal that we have been integrated into. So yeah, I'd like to remind our participants that our question and answer box is open for your questions, and we have some questions that were already sent throughout the talk of Mr. Alcala, and I think it was very nice to imagine, not to have to imagine, because there were maps. Maps is probably one of the words that's constantly being called to our minds these days. A lot of us have paid attention so much to maps, I think more than ever in our lives. I could say that for myself. Map. Sir, can we start the ball rolling with the question? The first question actually is based on something that occurred earlier this week. The participant who has asked to be anonymous is asking, our PPA, or our Philippine Ports Authority here, said that these islands will affect navigation. Geologically, is this a valid concern?
From my point of view as a geoscientist, I think the Philippine Ports Authority is more concerned with safety issues and I guess real estate issues, because their area will now be covered by the project, and they will be limited in their movement. But geologically speaking, I don't believe there is any connection with a PPA protest against this project. Although personally, um, um, I like the PPA speaking up against this project.
I think a little bit connected to that, someone also asked, the mayor said the island would have 10-meter canals. It's not very sure, but there's quite a distance of canals so that bangka, they don't have to go to the end of each island to get to deep waters. Would that address the flooding threat?
It would certainly help a little bit. Those channels connecting the lagoons, those channels will help move the water from the lagoons towards the ocean. But I don't believe it is enough, because once you create those lagoons, there will not be enough movement. The wave movements and the current movements in the coastline, along the coastline of Dumaguete, are very dynamic. So anything that you use, anything that blocks their movement, will create disruptions of the wave currents, waves and currents, and the dynamic processes. We don't know yet how it will exactly cause disruption, but I am sure it will be causing disruption.
I think this is something that I think we might have already even observed, like from the land area with the current works that they've done, and yeah, the disruptions that have I think been experienced by what we observed, like the waves getting into the boulevard that's been happening of late. And yeah, so on that note, I think this question that's asked also has something to do with disruptions and the introduction of who will do the project. So I think we've all already heard again, time and again, about the company that is presenting itself to do the project. But I think a few days ago, the mayor said that they were going to be um, subcontracted by this company, and the question involves that company. So uh, the participant is asking, on the unstable continental slope, our mayor said Polychangda, which is the company that is said to be subcontracted, is one of the best companies in the world. With a state-owned and presumably well-funded Polychangda, can they not introduce technology that would address the earthquake and tsunami risks?
I am not familiar with the track record of Polychanga or EM Cuerpo, but I can only say something about what I read. And what I read is that the contractor is EM Cuerpo, and they may be making arrangements with Polychanga, who appears to have a lot of money. It is possible, and if they do their due diligence, they can certainly mitigate these geologic risks. And that is one of the reasons that geoscientists like me are presenting these geohazards that should be addressed in any due diligence work that they have to do before they get the permit.
Thank you, sir. I think this is related to that since we're talking about permits. Um, the question from the attendee is, with the amount of filling materials needed for this proposed project, which you mentioned, which is about 23 to 27 million cubic meters, do you think that 23 billion pesos is enough for this project?
I am not an economics expert, but judging from what other economic type people have predicted, they're saying it's not going to be enough. And in fact, there are reports floating around that are saying that 23 billion pesos is just going to cover a small part of it. But again, I'm not an economics expert, but certainly 27 million cubic meters is a lot of money. A lot of trucking if they're quarrying from dry riverbeds, a lot of uh, dredging from the rivers, suction dredging from the ocean. That is a lot of money, a lot of zeros.
Definitely. So speaking of that point of reference in engineering, you've pointed out the high risk of liquefaction in Dumaguete. This anonymous attendee is asking. This is apparently a well-known concern among local engineers. Do you think that this reclamation project is at a much higher risk of liquefaction than the present coastal mainland?
Yes, that's what I am afraid of because once they construct the island, it will create that lagoon in the middle of the original, between the original coastline and the island. And that lagoon will be subject to stagnation of waters, subject to flooding, even though there's channels that connect them towards the sea, it will not be enough. So there's a risk of flooding. As I presented in one of the slides, a lot of reclamation projects around the world are plagued with flooding problems. So if you consider flooding as a high risk or a possibility in this case, flooding, as you know, fills up the soil pores with water. And once the soil is saturated with water, it tends to lose its cohesion. And when that cohesive strength is lost, and then all you need is a little earthquake to push down roads and buildings. And I believe there's already a small case of liquefaction along that road, the Piapia Road.
Yes,
I
yes.
saw some pictures of that. So, and historically, there is a liquefaction issue in Loo. Actually, there used to be a wetlands and river there that's been filled, but still underneath that is a lot of water, and um, uh, the soil is filled up with or saturated with water, just ready to collapse, given enough magnitude earthquake in the area.
And I think this question follows that path when uh, it goes, the geohazard maps are interesting, sir, but can you stimulate the tsunami or flooding that would happen if the reclamation project would push through? Granting that you've already introduced how it's going on in the coastal areas that we are in right now. And can you estimate how long these hazards might or would persist?
That is indeed a very good question. I am not into simulation of tsunamis. The feeble people, they can probably do that, given details on the construction of the island. I'm sure they can run simulation models given those details. But yes, a very interesting question. Right now, we have up to 5 meters of inundation along the coastline without the reclamation. So how much more if we have the reclamation project in there? Who knows how much water it's going to hold, especially in the lagoon part. Um, so yeah, good question. Although I'm not an expert, I'm not a simulation modeler for tsunamis.
Yeah, I think this is also quite interesting, sir, because we're brought back to what we have now with the Pantawan Dos or Pantawan 2. And I think as you mentioned this in the very beginning of your presentation, um, the participant is asking, are you seeing any negative impact from that reclamation that could potentially be magnified more than 100 times with this bigger reclamation?
Um, Not necessarily more than 100 times impact, if that's what he's asking, but that is a good question. As a matter of fact, um, can we bring up my slides? Because I'd like to show something. All right. Anyways, while he is doing that, my point is that the Banica River uh, is a source of sand sediments. And these sands are actually being distributed along the coastline south of the river, Banica, and north of the Banica River. North of Banica River would be the boulevard area. Um, and and I had mentioned this before. Oh, there you go. Um, there you go. The Banica River is over here, and that was a source of sands years ago before this reclamation project was implemented. So the sands mostly moved toward the south because that is the predominant longshore drift direction. That's why these resorts here to the south of Dumaguete are getting lots of sand, nice sand. That's mostly from years of deposit from the Banica River. The Habagat currents going this way to the north also contributed sand to the former coastline along the boulevard. And if you look at really old pictures of the boulevard, there was a small sandy beach in front of the boulevard. And that sandy beach got its sand from the Banica River, from the reversals of the longshore drift. Um, and by creating this Pantuan 2, it essentially stopped the distribution of the sands from the Banica River. Therefore, it is starving this area here, especially in front of this block, including Silliman University. It is starving it of sand. So there is no sandy beach here. In fact, it is going to be scoured and eroded if there is no supply of sand. And in fact, I would recommend that protection be implemented along the seawall in front of Silliman and the one block south of it. And that seawall protection could involve boulders and riprap called revetment for shoreline protection. Otherwise, because of the creation of this project, this unfilled, unreclaimed area is going to be subject to erosion. And that is what I fear is could happen.
Wow. Well, since we're talking about Banica River, I think that part is in what has been shown and what has been given to us about this project. I think that part been has not been talked about so much, sir. And thank you for actually highlighting that in your talk tonight. And I think that's something else that we need to think about. What the Banica is actually doing, or what it contributes to this whole cycle, the ecosystem, or the environment that this all belongs to. And speaking of the Banica, there is a question here that asks, um, does dredging rivers like Banica help with the problem of flooding?
Actually, you'd be surprised to hear it from me. Dredging of rivers, especially that are getting shallow and choked with sediments, is actually a good idea where the river is being choked. Because if you dredge a river, you're basically giving it more volume. So more volume, it's able to handle more water. It could hold more water and help in flood prevention. But this is the but. There's always a but.
Yes.
So the dredging, there's always a bad side of it. As I mentioned before, um, depending, I guess, on how long the project is going to be. If you're dredging a river for a very long time, you'll be creating sediment plumes for a very long time. And who knows what those sediment plumes are going to do to the ecology of the area, the fishes, the marine life, especially when the river discharges those sediments into the ocean. So there you go, marine life and corals and fisheries are certainly going to be damaged. And if it's a long-term project, years, several years, you'll have a long-term damage effect on the marine life.
I think it's not the first time that we heard that term, or the term sediment plumes. And this time it's from the rivers, which was not in, again, which has not been highlighted in any of the other talks that I have listened to. And I think that's something that we also need to consider in the light of things that are put in front of us these days. Speaking of rivers and the opening into the ocean, someone is asking here, sir, could mangroves prevent flooding and mitigate the geologic hazards that you mentioned?
Yes, mangroves are a very good shoreline protection measures, in addition to coral reefs, because a good coral reef in front of a coastline acts as breakwaters, and large waves that are approaching the coastlines could easily get controlled or broken by coral reefs. And if coral reefs are not enough, those waves could be broken by mangroves, a very important ecology. And I'm sure the marine biologists are going to tell you that it's a very important ecology. It's a fish breeding area. Lots of positive advantages of having mangroves along the coastline. Although it you know, from a layman's point of view, you go to a mangrove area, you certainly don't like the smell, and it looks dirty. But from the scientist's point of view, they'll tell you, let's keep these. It's a very, very important ecological part of the system.
There's that commonality with things that we usually as human beings don't appreciate, just like seagrass. Like we don't like seagrass so much, but then we now see how important they are even to us as human beings.
Yes, I avoided seagrass because I used to see a lot of sea cucumbers, and I got scared with the sea cucumbers. Um, it, and if you step on them, it was so scary. So I didn't realize how much the seagrass ecology contributes and the symbiotic relationship with corals.
Yeah.
Um, yeah.
Sir, there's somebody who's asking here, from what you presented, you could see that Dumaguete City looks like a punching bag of northeast and southwest monsoon. If the two man-made islands will push through, what are the possible risks in the areas fronting the area fronting between the two islands? So I think this is the Boulevard area.
Oh yes, that's the gap that the project is avoiding, and that involves the area in front of Silliman and about 1 block south of Silliman. So um, it is very possible that that area will be subject to erosion and scouring. And I mentioned before, since there's not going to be a fresh supply of sands coming from the Banica River, it's going to stay stagnant in terms of source of sands. So large waves, are certainly going to scour that area and could endanger the seawall of that area.
And speaking of endangering the area, someone's also asking, would it really take a tsunami to put this smart city at high risk? Aren't typhoons enough? Just like what we've seen in the fake Dolomite Beach in Manila Bay. Stronger typhoons are becoming more frequent because of changing climate. Your thoughts on this, sir?
I didn't quite get the first part.
Would it really take a tsunami to put this city or this island at high risk? And yeah, the attendee is asking if typhoons aren't enough to put this island at risk.
There, there are a whole bunch of geohazards, as I mentioned. But you know what? What I did not mention is that these islands are also going to be subject to subsidence, because once you add fill material to a certain area, years of compaction could cause the surface area to subside. So that's another actually geohazard, more of construction hazard, and could cause major tsunami inundation problems, flooding, aside from flooding, and tsunami, because that surface area could get lowered. That will be coupled by the sea level, global sea level rise, which could affect the Dumaguete coastline as well.
Thank you, sir, for clarifying that. Perhaps it's time that we bring the questions to heart of the land. Someone is asking here, and the attendee is opens with appreciation for your presentation. And he or she asks, Dumaguete, or says, Dumaguete sits on top of the quaternary alluvium deposits. Please correct me if I said that wrong, which consists of thick, unconsolidated sediments. Won't its natural resident frequency also contribute to the seismic risk of the reclamation project?
That sounds like a question from a geology student.
Yes, I was assuming that.
Quaternary deposits. These are alluvium. These are usually unconsolidated, meaning loose soil deposits, as opposed to a bedrock, which is usually solid deposits. Yes, and the presence of such kind of soil, loose soil, could add to the geohazard, as opposed to areas where you have shallow bedrock. If you have shallow bedrock, solid rock, you can do construction and rest assured that you will have lesser risks of liquefaction. But with a thick deposit of alluvium, um, it adds to the risk of liquefaction of soils, especially when flooding and earthquakes go together.
I think this could connect to that, sir. Or someone's asking the bathymetric map showing the continental slope and its steepness and abrupt drop looks dangerous. Can't our government agencies recommend against reclamation projects like these?
That is what I'm hoping that DENR or PRA would take a close look at this risk, because as I mentioned before, um, other reclamation projects are located in a pretty safe setting, shallow seas and very gentle slopes ranging from 0.1%, 0.14%. These are very gentle slopes that mitigate those risks. On the other hand, Dumaguete has a very um, steep slope. I call it the continental slope. And with a project being close to that edge of the continental shelf, it does pose that risk. And I am hoping that the government agencies that are going to look into the permitting process are going to consider that.
Thank you for sharing your thoughts with us, sir. Someone's also asking here, because we're talking about slopes. Um, the attendee is asking, it's becoming clear that dredging using cutter suction ships as opposed to quarrying is probably the more cost-effective way to build these artificial islands. Given this steep insular shelf of Dumaguete, do you think that these ships will obtain filling materials from the shallower parts of the shelf in neighboring towns such as Bacong and Sibulan?
It is very possible. The closer they can get to the project, the better. So they might try to dredge material from shallow areas like the continental shelf or the continental slope nearby. So the proper thing to do would probably be dredging from the deeper ocean, where it doesn't disturb the steep slopes of the continental slope, or it doesn't disturb the shallow continental shelf, where we do have lots of marine life. And that's what I'm afraid of if they start um, dredging the shallow part.
Thank you for your thoughts, sir. And with that, I think this would be a good question to ask now, since we have been bombarded with a lot of technical uh, terms. Someone's asking if you can please summarize in layman's terms your reasons why creating this reclamation project is geologically dangerous for the residents of Dumaguete City.
Um, you can take a look at my conclusions. Um, and that basically concludes, summarizes it. The geologic setting of the reclamation project involves too many geologic hazards, like I mentioned, flooding, liquefaction, earthquakes, steep continental slope, shallow continental shelf. These are factors that um, that lead us to the conclusion that this is not a wise decision. Just looking at other reclamation projects in the Philippines and around the world, it's just very unwise.
Can you probably, because one attendee is also interested, sir, if there is a similar reclamation project that was built on similar slopes as Dumaguete that now exists, if you're familiar with any, and probably how it is now.
I am not familiar with anything, any reclamation projects, but I haven't looked at all of them, many of them. But there might be some that are close to the edge of the continental shelf, but I haven't looked at any of them.
Um, Someone is asking if you have or we have simulations, perhaps one model along nearshore areas of Negros Oriental. Are you familiar with it, sir?
What model again?
SWAN, SWAN.
I am not familiar with such modeling program. Sorry.
All right. And then uh, an attendee also is interested to know about subsidence. Um, doesn't that suggest that the city will have to spend lots of tax money to maintain these artificial islands long after the contractor has finished, and just to keep up with the rising sea level due to climate change?
That is a possibility because um, whenever you fill a certain area with fill materials, uh, it may take a long time before it actually compacts. Some construction projects uh, include compaction measures. So once they put the fill in, they start pounding it so that it would get compacted. Other projects wait for a while, months or even years, before they start paving over the fill material. So subsidence is a hazard that has to be taken into consideration. I hope that if this project pushes through, which I hope it doesn't happen, but in case it pushes through, they should be compacting their material to avoid subsidence of the land. And as the person mentioned, the sea level rise could um, make it worse.
Yeah. Sir, can we compare what's being done here to what is done or what was done in Pasay City? Is it different? And if so, how is it different? This is one question from another attendee.
Pasay City being the reclamation project off of Manila Bay. I assume that's what it is. There's a bunch of reclamation projects being proposed and being implemented in that area. Um, so I know they have completed like the Shoe Mart, Mall of Asia area. The cultural center was completed a long time ago, but I am not familiar with what the Pasay exactly the Pasay City project involves and which one it is. There's a bunch of it.
But yeah, I think there's a bunch of it.
Yeah.
Speaking of comparison, sir, there is a question that cites a condominium or that talks about a condominium in Florida that was recently reported to have collapsed, and it was built on reclaimed land. Is this a possibility that you can project also if this islands will be built?
Yes, I was thinking of that. I was reading up on what the causes were for that building collapse, and I wasn't quite sure. The investigators have not quite concluded whether it was due to subsidence, sea level rise, or a combination, or liquefaction. So I am waiting for such reports, but I won't be surprised if it was caused by a combination of liquefaction and subsidence of the land. And whenever you have a high-rise building like that, and you have a combination of such factors, you can bet that you'll have some kind of damage to the building.
I think it's a whole complex factor of things, but I think, yeah, as you already shared with us
Could be
also,
a combination.
and these are the things that we need to think about, because I think that's part of everyone's dreams that is painted by this project, that the buildings and the bright lights, as they say. So I think this would be a great opportunity to think about it, and maybe put this in our discussions with our friends about our future. Yeah. Sir, there's somebody who's curious about what you mentioned a while ago about a portion of the extension road in Piapi that appears to be a result of liquefaction. Can this problem be fixed? And if not, what are the dangers of the road being further exposed to the threat of liquefaction? And what signs should we watch out for?
From my point of view, that road has been completed, and I don't believe any geological study was actually performed before they constructed that road. So to answer the first part of the question about mitigating that problem, the only way to do that would be to dig it up and to fill it with material and compact the material. Another mitigation measure would be to construct drainage pipes, because the groundwater, there is a natural groundwater coming out of the land into the ocean that is now being blocked by the seawall and the road. So if groundwater has nowhere to go, it normally discharges into the ocean. If it has nowhere to go, it's going to collect underneath that road and in the seawall. And there you go, you're going to have liquefaction there. So you got to have a way for the groundwater to discharge into the sea. So pipes, maybe discharge pipes, just to release the groundwater that's being accumulated under the road.
Thank you for sharing your technical expertise with us, sir. We're getting pro bono work from you already. But thank you. I hope some of our engineers have heard that, or if anybody here is friends with our engineers in the city, then we can lay that over to them. Speaking of maintenance, sir, someone is actually curious if it is or how costly it will be to maintain the integrity of these islands that are intended, since we were talking about maintenance work. How costly would it be to maintain 174 hectare island?
Good question. And I asked that myself. I am not an economist. I'm not an urban planner, but I'm sure there are urban planners that can make estimates from experience from other cities, other reclamation projects. But I'm sure it's going to cost a lot of money maintaining this new island. It's not going to be easy. Dumaguete is subject to storms, as I showed, currents, waves, tsunamis, earthquakes, you name it. We have everything. So it's going to be expensive, I would think. And I hope that somebody's going to take care of those expenses and not the people in case damage is done.
speaking of expenses, sir, I think this is part of the essentials also that we are concerned about. Wouldn't this smart city also result in a higher demand for fresh water? And wouldn't this cause a shortage of fresh water in the Dumaguete city that we have now?
That's a good question, and in fact, that will be brought up by somebody from the Silliman uh, Marine Lab. I don't know when Janet is going to talk about that, but I did discuss that with her. Um, this new city will definitely have a higher demand for water. Right now, our water supply in Dumaguete is coming from a network of deep wells. Um, and these deep wells, excuse me, at this point appear to have enough water. The problem is, uh, I think, the infrastructure, the piping and the pumping and the distribution of the water. I think that's where the problem is. But the groundwater supply, as of a few years ago, seemed to be able to handle the current population of Dumaguete. Now, adding the stress um, to the aquifer because of additional water demand from the city is going to be another issue that has to be addressed. So I think it could be modeled. The proponent, if they plan to submit their permit to the DNR, for example, should address the source of water and how much demand they're going to add to the water supply of the city and how much stress they're going to cause on the aquifer.
Thank you for sharing that with us, sir. I think, yeah, there are so many other factors that have not or that have been left unconsidered with this. And I'm very glad that the questions have brought that forward. And I hope that everybody is learning from everybody else here. Um, I think to put it all roundabout, somebody is asking if there is actually a technical and scientific difference between reclamation and island building. If you're familiar with this, sir.
Island building from Dr. Kent Carpenter. Yes, and indeed, for me as an environmentalist and an advocate, um, that is a scary proposition to be used in Dumaguete. And I think it's the same thing. The island building that they're doing in South China Sea is the same as reclaiming, where there was no land before. In fact, corals, they are destroying the corals and of reclamation. Legally, I'm not familiar what the terms or what the difference would be, but I don't know if Dr. Kent Carpenter had defined island building as opposed to reclamation. But that certainly is a legal question.
Thank you so much for answering all those questions. I'm very sure that everybody's night, their evenings have been the last few hours that set apart for this event has been well worth it. And we have a bunch of statements of appreciation here for you, sir. And I would just like to summarize because they're all saying the same thing. They're uh, thankful for your informative presentation that will hopefully allow a lot of us to think further about our future and about speaking up and speaking out about on our thoughts, speaking and moving out there with our thoughts. Because I think this is where we're coming from, or a lot of people are coming from. There's a lot of questions, and there's a clamor for answers. And I think this is why the organizations or the organizers of these events have done have organized these talks. So,
I
sir,
agree.
is
I agree. You've been doing a good job. Having all kinds of experts cover all kinds of topics. So this is certainly a very informative series.
I've actually also been learning so much in the past few days. And as a teacher myself, I think this is something that makes me so happy, having this much interest in things, and especially things that impact our lives, not just now, but the future generations. And with that, sir, I think that would round up the questions that were asked. Is there anything that you would like to leave our audience for tonight? Thoughts?
Yeah, I think I expressed all my thoughts, and I hope that people are now enlightened with this new topic of geologic
So
hazards,
much.
something to think about and to consider in the debate of the issue. And I hope you learned some geological lessons today. Uh, and
Definitely,
for
definitely.
thank you very much for attending.
Thank you so
Thank you
much,
very much
sir.
for hosting.
It was a very enlightening, more than enlightening evening. It was also quite interesting how we have been reminded of our of how thankful we have to be for technology, but how technology is also bringing people together, especially in this time of a pandemic. And I think it's quite an opportunity. One of the positive things that we look at, that was brought about here. So we have you all the way from New Jersey. Good morning, sir. And
You
to
know,
everybody attending tonight, thank you for sparing the last couple of hours of your evening. So many people are thanking Mr. Alcala. And with that, we would like to thank everybody in behalf of the Dumaguete City Host Lions Club and Rotary Club of Dumaguete South. Your joining us is we express gratitude for your joining us. And yeah, I think it is a challenge that we must put for ourselves to keep on learning. It is something, this is my life motto: never stop learning. And thank you, Mr. Alcala, for assisting us and opening our eyes to a lot more of facts, which is something that we really need these days to put or to allow ourselves to see more into the future. And yeah, so we close this evening with some announcements. This is not the last talk of the series. We still have next week, of course, August 9, that's a Monday. We start at the same time. It's the mayor's time. And for those who have questions, who have things that they would like to ask the mayor, or maybe your friends who are too shy or don't have time to join us, you can ask them what they want to ask the mayor, and you can ask for them. There is another talk on Wednesday. Dr. Wilfredo Licuanan from the De La Salle University Shore Center will talk about human impacts and the current status of Philippine coral reefs. On Thursday, Dr. Lori Raimundo, the director of the University of Guam Marine Laboratory, will talk about coral reef restoration, some of the things that have been put in the spotlight lately. So we'd like to ask everybody to kindly like the Facebook page, Learning Event Series, and be updated on upcoming events. The recordings of these webinars will also be uploaded on our YouTube channel, and the links will also be shared in the Facebook page. Should you have any questions that you'd like to ask in advance, you can send that message through our Facebook page. And with that, we formally close this learning event tonight. Thank you so much, everyone, for tuning in and for your valuable interest in new information. Good night, everybody.